Hi there. Welcome to another edition of DesignSpark Ask the Expert. Today we're going to be talking about smart and efficient homes with TE connectivity. TE connectivity is the hidden gem within the connector world. It's in the products that we use every day, and having TE connectivity in those products ensures reliability, robustness, and operation and safe use. Today I'm joined in the studio by Joshua and Ifram. Hi guys, would you like to say hello to DesignSpark and tell us a little bit about yourselves?
Sure. Hi, my name is Josh Potterjoy. I work for TE Connectivity in our engineering appliances division. My current role is within system architecture and product development.
Hi, my name is Irfan Youssef. I'm a product manager for antennas in the Data and Devices business unit.
Fantastic. Guys, if we think of the smart home and the devices within it, what we do is we discover a multitude of power and connector variations from mains power outlets right down to the board level electronics. Power connectors play a key role in keeping everything switched on, operational and safe. So from across this gambit of different connectors, what are we looking at when it comes to the challenges of power connectors, their design, but also their integration within signals, sensors, and switching, for example?
Yeah, sure. When you think about appliances, it's a extremely complex landscape. So if you think about the variety of appliances you have in your home, anywhere from small uh, countertop appliances to the large washers, dryers, even refrigerators. So power runs all of these. Power is the lifeblood for these appliances. And there's loads of challenges when we talk about this holistic ecosystem of appliances. So typically, when I think of the challenges, though, I usually think of safety as one of the largest, then assembly, and then followed by flexibility. Of course, safety is certainly an end user application. Safety is what keeps our appliances running and operating in a safe manner in the home. And we're not just talking about how the connectors or how those connections are being made, the conditions are being run under. Of course, everything we run, we have tested to the fullest capabilities of the products. We're looking at temperature ratings, we're looking at voltage, we're looking at current, but there's also things that may not be as obvious, such as material ratings. So, is this material flame resistant? Is this material what we call glow wire compliant, which is really a test for looking at when you heat up terminals, do the plastic housings melt or do they light on fire? So, these are some very critical areas we look at with our connector designs, as well as making sure that they meet all of the local agency ratings, getting those UL or VDE stamps of approval, which is extremely important for our appliance products. Another big area, of course, as I mentioned, is assembly. So this is more from the manufacturer's perspective, but this is a massive challenge if you think about the high volume scope of the appliance industry.
Yeah,
So making millions and millions of connections a day can be a challenge. So things like low mating force for those connectors is extremely important, especially with those very large power connections. And this is also something we look at as far as how does the operator grip the part? Are they using the right ergonomics? Are the latches in the right location? So all of these critical factors really play in to the design of these power connections. And finally, as I mentioned, flexibility. So, as I said earlier on, there's a lot of diversity in the appliance ecosystem. So, having product lines that can meet those different challenges, have those different accessories when needed, and just be able to expand or contract depending on the end use of that product is extremely important to us.
absolutely. So, there's a whole host of different criteria there to take into consideration, and if you think of the home, the smart home, for example, there are many different environments within that smart home as well. So in terms of ensuring the reliability of the product, the safety of the product, and then also the capability of that product is really important to make sure that end users are actually specifying in the correct parts with the material safety ratings, thinking about the actual functionality and the end use of those products that they're going into. So that really is a good summary from yourself, Josh. There, when I think about smart homes and energy efficiency within the smart home, for example, there's a few things that we also rely on, signal integrity, sensing capabilities, but also if we're looking at, particular areas within the smart home, for example, if we look at the kitchen or the food preparation area, what we're seeing is appliances becoming not only smarter, but to some extent they're becoming smaller because the real estate on the worktop is so I was going to say so expensive, but it's not expensive in the terms of area, but in terms of actual the use of the real estate on the workshop, the products have to be practical. So how do TE connectivity approach these problems if we're looking at maybe appliances within the kitchen or food prep area?
Sure, I can take this one at least to start. And I'll say one thing, and I think you nailed it. It's the appliances, especially in the kitchen, is becoming a very interesting landscape. Our appliances are becoming more like, I almost look at them as cell phones. They're doing a task, but they're also including a lot of electronics. There's usually an advanced user interface, advanced sensing going on in these things, and we think this is just going to accelerate with the advent of AI technology driving that automation even further. So miniaturization is a must-have. So we get a lot of requests for miniaturization from our direct customers, and miniaturization can happen in multiple forms. But some areas that we really focus on are first high density. So how do we increase the pin count or the number of connections within the same size connector? So that is a form of miniaturization, and it's something that we strive to achieve on a lot of our newer connectors. The one challenge we face there, though, is, as I mentioned, with the power connectors, the more connections you have, the higher the mating force. So there are different ways we try to solve for this. We have some applications where we have lever assists. We have lower mating force lubricants that we can use really to help with that new product development. The second thing we actually run into is more of I think, a technical materials issue. So as you shrink these connectors down, your materials become much, much more important when you're talking about wall thicknesses, maintaining those electrical properties. You start getting into a realm of material challenges. So that is one area where our engineers are very focused on getting those right materials, those materials that can be processed at such small scales and meet those tight tolerances for these newer connectors, which is very important. And then finally, as these connectors shrink, handling becomes much more difficult. So something you may not think about as an end consumer, but definitely, again, you think about this when you're doing your assemblies.
Yeah.
Handling such small connectors can be a huge challenge. So making sure that the latching is very robust, the handling is very obvious for the end user is really important to us because, again, if they can't be installed correctly, they're not going to work correctly in the field. So from my standpoint, I think those are the main challenges we face. Um, but
Yeah. And I would like that from the connectivity perspective, right? So as we said, the devices are becoming smarter and smarter, plus smaller and smaller. So the miniaturization trend is definitely there. And from so if the device is smarter in some sense communicating with through one or multiple wireless technologies, that means
Hmm.
there are certain antennas integrated in there, right? So if you're using an app to control one of the devices or appliances in your home, you have some kind of wireless technology that is in there, and there are antennas there. So both those trends of robust or rugged environments plus miniaturization, that really puts higher requirements on the connectivity part as well. Right? You want to integrate more and more wireless technologies, but simultaneously your PCB is getting much smaller, as you said.
Hmm.
So, and when you are going for miniaturization, the antennas, they need some kind of free space to radiate the energy to the outer world, right? But when you are sitting so compact with the electronics and the PCB and the device itself, right? So it becomes a great challenge to integrate the antennas. And even though many times you can use an off-the-shelf standard antenna, but when you are really designing very compact products, you have to think from the antenna perspective from the very beginning of the device concept. Because if you so in some ways we used to say that you have to design the antenna first. You have to think about the wireless technology and then design the device around it. Because
Yeah.
if you do the other way around and you design the device and you want to bring the antennas in, normally that doesn't work. You have to go back to the drawing board, and that takes away lots of development work, lots of time, project cost, things like that. Because if you go to redesign because you did not think about the antennas early phases of the concept, it's a bad story.
Yeah.
So definitely in those kind of devices, if you are thinking multiple wireless technologies, if you are in miniaturized devices, you have to put antennas or wireless connectivity quite early in the concept. That would and in there we can from TE side help you understand and make the right design compromises, explain to you the right constraints that you can have or you should have to make sure that we make the best use of the space available in the device to have the optimum wireless connectivity performance.
Fantastic. That's you've touched on there, Ifran, a real, you know, design issue that you need to take into consideration and factor for. So I never kind of placed it in that situation. Think of the antenna first because of the space around it. So when we talk a lot about the miniaturization, we're talking about board density, but at the end when you start to design, if you get to the testing process and the signal integrity is not there because of the pure factor of influence from components around the antenna, that is a really costly mistake to make. So what you're saying there about starting from the antenna and then maybe design out into the factors. So in terms of the end user, the thing that's they're really looking at is the reliability of the product when they get it. They don't take all this into consideration, and why would they? So it's really really a good design point that you called out there. So thanks for that that insight into that area. And as you said, T connectivity will help users consider what they need to do with the signal connectors, for example, within the smart home. I want to talk about maybe some of the environmental considerations. We spoke about the materials that are going to be used, obviously, within the products themselves, but within the smart home, for example, that there are going to be many different environments. There's the laundry room, which is quite different to the living room, and if we do factor in things around the laundry room, I would imagine that there's more factors like vibration, if we're talking about dryers and washers, for example, and the day-to-day operation of those products, maintaining the capability, when things are on their spin cycle, we have vibration, we have excess vibration. Josh, you were talking about connective mating. So how do we actually, look at things within the different areas if we were focusing on maybe, those washer-dryer combinations?
Yeah, so I'll actually take it one step further. When you think about appliances, like you brought up laundry, for instance, but we're also looking at trends that go a little bit beyond the home. So when you think about what's happening in your garage or your tool shed outside, we're seeing this huge transition from gasoline, fossil fuel power to battery,
Mm-hmm.
and I think this exacerbates that issue. So now you're talking about the electrification of more products. Um, Taking something that was mechanical based, so you think about a throttle body or a carburetor, replacing that with a battery system, you're now putting in sensors and switches. So you're taking these extreme environments and they're still falling within the appliances realm. So building connectors to satisfy small appliances sitting on your countertop all the way to a lawnmower or a weed trimmer sitting in your garage. So there's quite a gambit of environments that we're looking at here.
Yeah.
So uh, a few ways though that we usually manage this, and you mentioned vibration, so I think we can cover that first. But robust latching is certainly a needed application here. We have special features within our connectors, not just the mechanical click latches that you'll hear when you put them together, but also the TPAs and CPAs. So these are small accessories that we use in our connectors, one to lock those terminals in those housings. So once they're assembled, you can push these secondary pieces in to keep them in place. This also helps with vibration, keeping them from sliding out or eventually working themselves out. Same thing with these CPAs, they lock the two connector housings together, preventing them from moving. We also look at things like float within our connector designs, allowing our mechanical or plastic connectors to mate together, and then the terminals inside have some free movement to avoid some of that vibration that may be happening on the overall housing. We apply things like fretting lubrication to those connections to also help with that, that mechanical motion that we see within these new devices. And we see this both from power and signal applications as well. So it's not just an
Yeah.
issue with replacing power connections, but it's also how do we get those signal connections more robust, especially in these harsh environments.
Yeah.
Yeah. And on the antenna side, yeah, we mentioned vibration, but also in those kind of applications, laundry room and moisture is also one of the concerns because yeah, it's a humid environment, and at a certain point the water does or humidity does impact the PCBs, right? So there's chances of corrosion or the solder points kind of getting broken. So there's both on the connector side, we have locked connectors on the RF connector side to connect those antennas to make sure that the connectivity is reliable. Secondly, you can do some kind of conformal coatings, but the design considerations, as you said, are quite different from a smart lighting in a living room to a washing machine in the laundry room, right? So we really need to also think about the connectivity from the environment perspective. And yeah, as Josh said, going a step further, for example, smart meters, sometimes they are in a metal cabinet, right? Your electricity meter that's communicating or giving you different kind of informations to know, okay, you can control the energy consumption in the room or something like that in the house, when you should start the dishwasher, when you should start the EV charging for your vehicle, things like that. So those are also um, tough environments from antenna perspective, because either you're in the basement of the house where your meters are sitting,
Yeah.
or either you are in a metal cabinet somewhere for safety reasons, of course,
Yeah.
and you want to communicate out of them, right? So all the prerequisites the antenna needs to communicate, they are kind of being taken away, but at the same time, the expectation is to have very robust and rugged kind of reliable kind of connectivity. And so it's two opposite trends, but this is where I would say, I mean, we need to also think from the wireless. Yeah, wireless connectivity was good to have, but right now some of the products are integrally dependent on connectivity right now. You can have a great product, but bad connectivity, and you get a reputation of that. Okay, this product is not good because,
Yeah.
but the product is doing excellent by its function, right? But the connectivity is not good, and that's what drives the sales down. So connectivity has, in some sense, become integral part of it. So again, on those robust environments, as Josh said, there are special considerations on selection of the products. I would say on the similar side, antennas also have special considerations to be made for those environments.
Yeah. That's a really good point you're making there, Ifran, is about the considerations for design, because the point you make about the product actually operating correctly, if we're not getting the communication that we're requiring, then obviously the product may be working, but for the user experience, you can have that disassociation with the unpracticality of actually using that kind of application. When we were talking about environments, for example, Josh, you mentioned there about outdoor use, when we're talking about, moving away from the fossil fuel powered activity more into the battery operation. But one of the things I always think about as well when we're talking about outdoor use is the considerations around IP ratings. What would we need to account for when thinking about outdoor use or use within maybe a harsher environment? But again, it comes back to what you were saying, Ifran, about the design considerations that you need to take into your product and the end use. So is there anything you can tell me about the TE portfolio, how you meet these challenges, and are there other areas of information that the designers need to consider, for example?
Yeah, sure. So, IP or, just sealing in general is a critical factor for a lot of our customers. So we're seeing that grow as well. So You're seeing sensors show up in places they've never been before, inside of oven cavities, inside of washing machine
Yeah.
cavities, inside of dishwashers. So some type of sealing in some way or another is being pushed in a lot of these different applications. And you'll see even in our product lines, we'll have sealing options for many of our connectors. And I think the interesting thing with sealing is there's many different levels we look at. So there is the higher IP67s. Those would be the more watertight applications. You'll see those in more outdoor lawn and garden where you're seeing direct water jets, or maybe something like in a dishwasher where it's going to be exposed to strong jets of water from the sprayer arms. But we also have applications like bulkhead connectors. This is very common in HVAC applications. So you
Hmm.
have a panel separating the indoor and the outdoor portion of the unit. Maybe you're protecting a board, but you need to get power out to the fan or the compressor. That's not always exposed to water jets. Maybe you're just looking for something that's good enough. So just a humidity seal. So this is where we have different types of panel connectors, like these new twisted lock designs that we have with our Power Versalock product. That's a tight fit, but it's not necessarily a seal, but it's designed to operate in these moist or damp environments. It also allows water to drip away from the connector, preventing water from pooling in there. But again, like
Yeah.
I said, it's application specific, but we do have a lot of these applications, and you'll see that reflecting in our product portfolio.
Fantastic. Yeah, there's a lot to take in, when we're designing applications, for example, and it's more apparent than ever that designing in reliable connectivity with the features that you're talking about is really paramount to the overall success of the product. And you guys, from T Connectivity, like I said before, you're the hidden gem within the connector world. The products we interact with on a daily basis, making sure that they're efficient, reliable, and actually do the job that they're intended to do. I just want to talk about efficiency. It can be provided in several different ways, from smart design, the reduction of energy consumption through, as you were talking about earlier, Josh, about material choice, but then also, Ifran, what you were saying about, the considerations for design. So also source and products as well when you're talking about efficiency. And, obviously with TE connectivity, having the big global footprint that you do, the sourcing of your products is obviously not in question. But in the scheme of everything, if we're talking about smart home and efficiency, could you just maybe summarize what your approach is as a company to this?
Sure. Do you want to go first, Irfan?
Yeah. So yeah, and I would say sustainability is on one of the top points in TE connectivity, and TE has been working on sustainability for quite some long time now. So we have a head start here, and if you see, TE has yearly been publishing the sustainability report and our carbon dioxide global footprint optimization. I think the latest report for this year was released 2 or 3 weeks ago, and we have been working on this for quite some long time. Going to my own product portfolio, so we are now, and this is our intention, but also our customers' demand right now, right? They ask for green polymers to be used, or green plastics to be used for the antenna design itself. So there's a lot of customers where they uh, they are also working on those sustainability goals. So it's naturally drives us towards looking for new innovative solutions, even for small components as like antennas, to see that we are making the right material choices there. But
Fantastic.
then there's the also the manufacturing process of it, right? How much electricity is being used in our plants, in our manufacturing locations, how sustainable that cycle is, right? So it's not just the product itself, but the whole process of actually manufacturing and producing that behind that is being reviewed by us, and trying to continuously improve that process to make sure that we achieve our carbon dioxide and our sustainability goals.
Yeah, and I can elaborate on that as well. From a connector standpoint, we are looked as an engineering technology company, but we have a massive manufacturing footprint. So a big piece of that, as Irfan mentioned, is just our manufacturing waste, reducing material scrap, reusing that material, also transitioning to low carbon emission power generation. So using alternative energies for our plants. That's one of our big targets. The other thing too, maybe not as obvious, and Irfan mentioned it as well, is switching the resins to more bio-based, greener materials. Now, small connectors, they may not seem that impactful when you look at an overall appliance size, but we do
Hmm.
sell a lot of these things. So we're,
Yeah.
we're putting a lot of these connectors out in the market, and we do have products now using these bio-based resins, and we're starting to push more of these out. But we're seeing huge improvements. So CO2 reduction up to 45% on some of these new bio resins. So
Yeah.
as we push this into the future, I see a lot of applications in sustainability and efficiency.
Fantastic. Josh, that's really an important point to make on sustainability by switching materials out. Yeah, like you said, the individual component you would look at and think, okay, does that make much of a difference? But when you factor in the actual scale of what that actually
Mhm.
represents and those reductions that you were talking about making, you can see how quickly, that from what you guys are doing on the materials level is only adding to, the sustainability factor for your products. Now, just before I finish, I was doing some research prior to obviously the call, and I've got written down in front of me here the TE product value. So I just want to just say those out loud to the viewers. And through the course of the conversation, I think you've covered each and every one of these. So it's sealing, reliability, miniaturization, simplification, and safety. And I think really, through the course of our conversation here, we've covered all of those values. So for me, for DesignSpark, thanks for joining us in the studio today. I hope we can have you on DesignSpark again soon. And yeah, just like to say thanks, guys, for giving us such a great, insightful interview about the world of smart home efficiency, but also T connectivity.
Thank you so much.
Thank you. Thank you for the opportunity to go through this and explain some of the thinkings on our side and how we can support those key attributes that you mentioned.